Hello everyone, welcome back to Pepcoding. So the question which we will discuss today is called Reconstruct Itinerary. So first let us understand the question and then we will head over to the solution also. So basically what is happening is that over here we have a few stations, alright, and we have the paths that we can go from JFK to SFO, JFK to ATL and so on. And we have also been given a few tickets. So first let us construct a graph for it. I have JFK, SFO and ATL. So they are saying that I can go from JFK to SFO, JFK to ATL, SFO to ATL, ATL to JFK, and ATL to SFO. Alright, so this will be my graph, right? Now what I'm being told is that I have these tickets and the demand of the question is that I have to travel between these stations in such a way that I use each ticket exactly once. So that is the question which we have to do. Okay, so basically you have to travel between all of these paths and you have to use each tickets exactly once. That means that you have to visit each edge exactly once and not more than that, not less than that. So if you remember what we've done in the previous questions, you would immediately notice that this is a question which follows Eulerian path, right? So Eulerian path. If you don't know what Eulerian path is or you haven't watched the video for it, please go and watch the video, understand the concept of it, and then come back and continue this video. You will get a better insight of the question. I'll just give you a brief of it. Basically, what happened was that in the graph, we had a vertex whose out degree was exactly 1 greater than its in degree, and another vertex whose in degree was exactly greater than whose in degree was greater than its out degree, and the rest of the vertices fell in between. So the vertex which had its out degree greater than in degree was our source, and the vertex which has its in degree greater than out degree was the destination. Okay, and the rest of the vertices had the out degree and in degree exactly the same. Okay, so you will understand this better if you know about Eulerian path, Eulerian circuits in both directed as well as undirected graph. And if you haven't watched those videos, if you don't know about them, please go and watch the videos. It has been discussed very nicely and you will understand the concept better. Okay, now coming back to the question, we have to print the path, right? We have to print the path of traveling between these stations so that each edge is visited once. So if I do that over here, let's suppose we are told that our source is JFK. So we have to start from JFK only. Now, like any other question, when it comes to path, the immediate thought in our head would be that let's go for DFS. We will go through a path and we will keep on adding it as and when we will travel it. Right, this is right. But the problem is it would have been correct if it was an ideal situation, if it was any other question. Now what we have is we have a constraint. Okay. And what will be my constraint? What is my constraint in this question? I have to go from one vertex to another in lexicographical order. So basically over here, in this case, we can go from JFK to ATL and JFK to SFO also. But in lexicographical order, ATL will come before SFO. So I have to travel in that manner only. That is my constraint over here. Now if I go for normal DFS, right? What will I do? I will go from JFK to ATL according to lexicographical order. And then I will go from ATL, I can go to SFO only because JFK will be visited. It will be visited. So I can only go to SFO. From here, I will go to SFO. And then ATL will also be visited. SFO will also be visited. So from SFO, I will not be able to go anywhere. I will get stuck. And the basic demand of the question that we have to visit each edge visit each edge exactly once. That demand will not be met. So we will be stuck in our question. That is why we cannot use normal DFS in this question. So what will we do now? I am saying that when we go mark visited, right, I am saying that instead of vertices, I am saying we will mark edges. Okay, so let's try to work with edges. I go from JFK to ATL. Then I go from ATL to JFK. Now I can do that since the vertex is not marked, edge is marked. So I can easily go from ATL to JFK while following the lexicographical order. Then I will go from JFK to SFO. Then in lexicographical order, I will go from SFO to ATL and from ATL to SFO. And done. After that, we cannot go anywhere. So now let's write down the path for it. And I will write down the path in the back while going back. So from SFO, I can now not go anywhere, right? So SFO will be my destination. And then I will backtrack from here, right? Then I reached ATL. I reached ATL. From ATL also I'll backtrack. So I'll reach SFO again. Over here I have SFO. Then I backtrack. I go to JFK. So over here I have JFK. Then from JFK I will backtrack. I will reach ATL. So I get ATL. And from ATL I will backtrack again. So I will reach JFK. Okay. Now I added these in the reverse order, but I will print it in the correct order only. Now a question arises that why can't we add these while moving from the front itself? It will be easier. Let's try to do that. Okay. So I go from JFK to ATL. JFK to ATL. Then I go from ATL to JFK. Then I go from JFK to SFO. Then I go from SFO to ATL. And then I go from ATL to SFO again. These are the same. Why do we have to go for the reverse order if we can go in the front order only? Why do we have to make an extra step, right? Correct. But I am saying that it is compulsory for me, it is absolutely necessary for me to add these paths in the reverse order only. Let's see why. I'll just rub this off. Okay. Now I will explain why we are doing so. Let's take another graph. Okay. So I say I have JFK, I have SFO, and I have ATL. And over here, this is one path. And this is what my graph is like. So I will try for back in the back manner also, backward manner also, and I will go for forward manner also. So let's say I'm going with backtracking one first. I go from JFK to ATL. I cannot go anywhere from ATL now. So ATL will come over here and I will backtrack. Then I go from JFK to SFO and SFO to JFK. I backtrack from ATL. So JFK will come over here, right? Then after SFO, I cannot go anywhere, right? So I will backtrack from here. JFK came over here, right? And then I come to SFO. And from SFO, I will again backtrack and I will go to JFK. Now let's see this in the forward manner also. So JFK to ATL. Then after that I cannot go anywhere, right? I cannot go back to JFK also and I cannot go to any other place. So I backtrack. Then from JFK I go to SFO. Then from SFO I go to JFK. Right. Now what happened is two things are noticeable. One, ATL should be the destination as I cannot go anywhere from this place. So ATL should have been my destination. It is met over here. Another thing, over here in this case, we can see that it is giving me a path between ATL and SFO, which is not even possible. We don't have a path over here. So this became wrong in case of forward, right? So in multiple graphs, I will come across a condition where if I add the path in the forward direction, I will get the wrong answer. So I have to move in the back direction. That is absolutely necessary. Now another question is, how will we mark edges visited? See, we are working with a graph. Our graph I will store in a hash map. Over here, that is, I require only this much. Alright. Now in this graph, I am taking two things. One will be my string of stations and another will be a priority queue. So string will be for stations, that is JFK, ATL as well as SFO. Why did I take priority queue? The reason is that over here I need the neighbors of my station and I want them in the lexicographical order. So priority queue will help with that. ATL can go to SFO as well as JFK and SFO only has ATL. So when we will be working with this graph, right? Over here, when we will be working with this graph, how will I mark my edges visited? Over here, this is my graph. So I'm saying what I'll do is, I will simply remove the edges. As soon as I'll visit it, instead of marking it visited, I will remove it. That's it. Now you can not go to this graph again. Yes, it will ruin my graph, but in this question, I don't need to keep my graph intact, so it doesn't even matter. But if at all you say that you want to keep the graph intact, you can take a hash set, and in the hash set, you can mark whether or not an edge has been visited. That will also be the correct approach to the question. Okay. So now we'll try to code this. 1 second, I'll just remove all of this. Okay. Now, we'll try to code this now. So the first thing which we need to do is we need to create our map, hash map. So we have unordered map of the type string and multi-set of string. Okay. And its name is graph. And also I have a vector of string whose name is answer, or let's say itinerary. Alright. Then the next thing which I need to do is that I need to check whether tickets dot size is equal to 0. If so, directly return itinerary as it is. Right? Okay. Now the next thing which we will work on is creating the hash map. So for pair of string comma string, because the neighbors will be of string type only, and let's say it's each ticket and we are moving in tickets. So we will go in the graph of each ticket dot first. In that we will insert each ticket dot second. Okay, so this is what we will do. So we've created the neighbors. Okay, now the next thing which we need to do is I am taking a stack of type string and I am naming it TFS, and to that I am adding or pushing the source which is JFK. Okay, then after that I am checking while the stack is not empty, I will get the top station. So string top station I will get from DFS dot top. Okay, after that I will check that if graph of top station is empty, that is graph of top station dot empty, Then what will I do? I will go to the itinerary, and in this I will push back the top station. Okay, and I will pop it from the top. So this was added to the path. Otherwise, DFS dot push, what will I add over here? Graph of top station dot get 0. Okay, or you can say graph of top station dot begin. Okay, over here this will be ended over here. All right, so then after this, graph of top station dot erase, I will remove it from there, dot erase graph of top station dot begin. Okay, after that what will I do? See, here we have done something wrong with the brackets. Now I have made my itinerary, but the problem is that I have it in the reverse order right now. I added the destination, then the one before that, then the one before that, right? So when I was adding, I added ATL first, then SFO, then JFK. But over here, I am adding them in such a way that I will get a string of this type. Now I want it in the reverse order. So what will I do? Over here, I will reverse the string now. So reverse itinerary dot begin, comma itinerary dot end, and then I will return itinerary. Okay, itinerary. All right, so we are still working on the test cases of this question, so I hope you will understand that, but have faith, the code is correct. Please try it yourself. Okay, and I hope you understood the basic concept of the question, because that is more necessary. So thank you for watching the video. We will see each other the next time. Keep practicing, and until then, please like, share and subscribe to the channel. Thank you.